PEB versus conventional steel frame design. In conventional steel buildings, standard-sized hot-rolled sections are used for beams and columns. That means each part of the member has a constant depth, so areas of low internal stresses are in excess of design requirements. On the other hand, PEB frames are cut from an extensive inventory of standard plates to match the frame geometry with the shape of the internal stress diagram. This minimizes material waste and reduces the total weight of the structure. Z-shaped roof purlins and wall girts are used for the secondary framing. They are lighter than the conventional hot-rolled C-shaped sections in conventional steel buildings. Nesting Z-shaped purlins at the frames allows them to act as continuous members along the length of the building. This doubles the strength capacity of the Z-shaped members at the laps, where the maximum internal stresses normally occur. PEB versus concrete buildings. A concrete building is suitable for short spans of 5 to 8 meters. It becomes complex and heavy when the span increases. PEB buildings are suitable for clear spans of 20 to 30 meters, and can be designed for even larger spans. Cantilevers are also easy to design and construct at no additional costs. To modify a concrete building, the contractor may need to break part of the old structure. On the other hand, expanding a PEB building simply means adding more bays, and connecting new secondary members and cladding to the old building. Precision installation of heavy equipment such as cranes can be an issue in concrete frame buildings. I-beams and platforms have to be used for such installation. As for PEB, such equipment can be installed with ease and multiple cranes are possible within a building. Sways can be controlled and precision can be achieved during installation. Many factors can lead to quality deterioration in a concrete building. In addition, concrete strength cannot be guaranteed without testing, and concrete properties change over time with environmental conditions. Steel is not affected by site weather conditions. With precision fabrication, quality can be guaranteed. Steel strength is also assured from design, and steel properties remain stable with time. For concrete buildings, fabrication must be done on site and the construction process has to be sequenced, leading to time-consuming erection. On-site noise, dust and water pollution will be expected during construction. On the other hand, PEB members are precisely fabricated in a controlled environment and delivered to site in sequence and on time. It reduces fabrication time on-site greatly, assisting with the project schedule, a clean worksite and less site storage. Erection of exact members according to plan is also quick and dust-free. Concrete has poor flexibility under seismic conditions, and heavy structures will exacerbate the seismic effect on the structures. Steel reinforcement is needed to prevent brittle failure. Steel strength and ductility makes it a safe choice for earthquake-prone or volcanic vibration areas, and enables excellent performance under high lateral wind loads. Ductility also provides early signs of failure when overloaded, allowing the problem to be noticed and fixed.